Hi, today's notes are on 10.5 and we're going to be talking about permutations and combinations today. So we're going to start with permutations. A permutation is an arrangement of objects in which order does matter. Okay, so for instance, how many different arrangements of the letters A, B, and C are possible? So we can do a tree diagram just to see this real quick. We'll do A, B, and C. Sorry, I'll give myself a little bit more space for A. Okay, and so if I choose A, then I have two options left for the second one, right? I can do B or C. If I choose B, then I could have the second letter be A or the second letter be C. If I choose C, then I could have A or B as my options. So far, so good? Well, if I choose A and B, then my last option is only C, right? So, and then this one is B, B, A, the last letter is C, B, C, A. This one is B, and this one is A. So you'll see, like, based on this, right, there are 6 possible outcomes. Well, this was nice and easy for like 3 letters, but what if I wanted to ask you about like 20 letters, right? Or 26 different, how many different letter combinations are there for 26 letters? So let's take a look and see if there's a faster way. If you've noticed, right, what we've done is we have taken, if you have, let's say 4 letters, let's see what happens. Okay, so the trick is that if you have 4 letters, then you can do 4 times 3 times 2. I'm going to write here 4 letters because it says all, but how many are there in July? 4 letters times 1, sorry. That equals 12 times 2, 24 possible outcomes. For letter A, if I wanted to rearrange the letters of July. Now, what if I only want 2 of the letters? Well, we could take J-U, U-L, L-Y, and Y-J, right, for the first one. And then you could skip J-L-U-L, U-Y, right? So what really happens is that you have 4 options for the first letter, and then you have 3 options for the second letter. And the third and fourth letter don't matter because we're only picking 2 of them. Okay? So you take a moment, see if you get your answers correctly for these 2. Show your work, please, and you should get 120 and 60. See if those are your answers. Well, what you did in example 1A, or what we did, was we evaluated 4 times 3 times 2 times 1, right? So I'll write this in red. 2 notes. 4 times 3 times 2 times 1. This expression can be rewritten rather than writing it all out. There's a symbol to represent that, and it's 4 factorial. Okay, so let me write this in. It's read as 4 factorial, which is exclamation point. Exclamation point means that you take that number that you're given, like 10 factorial, be 10 times 9 times 8 times 7, all the way down to 1. Okay. As a special case, we need to establish that 0 factorial is an exception to the rule, because if we multiply by 0, you have nothing, right? So we're going to assume that the value of 0 factorial is 1. And this is like an established rule. Mathematicians made this rule up to make everything else in the future work. So rather than like just writing all of this out, right, or even using 4 factorial, because 4 factorial wouldn't work here if I'm choosing some of the letters, we're going to use a different formula. And this is the formula for permutations. Okay. So the total number of permutations in n objects is given by the formula NPN. And that's the same as n factorial, where n is any number. Okay, so this is like total. So for instance, if we have 4 objects, we could do 4p4 equals 4 factorial, which is just 4 times 3 times 2 times 1. Those don't look like multiplications. Okay, which is 24. Well, if we want to take sum of those 4 objects, then you need to have a different formula. And so this is the formula NPR, which is n factorial over n minus r factorial. Okay. And so how would we do this? Well, if we're taking 2 of the 4 objects, n is your total. Okay, so total is n. So I have 4 choose 2. And so n is your total, which goes on top. And then we're going to divide by 4 minus 2 factorial. So how do we write this out? We're going to have 4 times 3 times, let's write this, sorry, let me show you a different way. 4 factorial over 2 factorial. Please don't simplify this and make this 2 factorial. What this is 4 times 3 times 2 factorial over 2 factorial. Now the reason why I didn't like write out 2 times 1 is what if this was like 10 factorial over 8 factorial, right? I don't want to cross out 8, 7, 6, 5, 4. So we assume that at the end, whatever the denominator is, you're going to cross that factorial out in the numerator as well. So this gives us 12. Okay, so these 2 numbers confirm that our formulas are correct given 4 letters and picking 2 of the 4 letters. So let's do some practice now. Okay, so let's imagine now we're using a permutation formula. 10 horses are running a race. How many different ways can the horses finish? Okay, so this is like using all horses. So this is 10, and then I'm going to choose 10, right? So 10 choose 10 is the same as 10 factorial. If you plug this into the formula here, right, you'd have 10 factorial over 10 factorial. 10 factorial over 0 factorial, which is the same as 10 factorial. Okay? So now let me teach you a better way of doing this. So rather than writing this all out, there is a factorial button on the calculator. Okay, so where do you find it? You go to Math, and then you scroll over to Probability, and then you hit the number 4, which says factorial. And I don't have a number, so I need to input 10 factorial, which is, that's a big number, 3628800 outcomes. It's a lot. Okay, that's why like horse betting is pretty intense, because there's so many possible different outcomes. Okay, so now let's assume that we only care about first, second, and third place, right? So how many different ways can the horses finish first, second, and third, assuming there's no ties? Well, that means I'm taking 10, and I'm choosing 3. And notice it matters about the order because first, second, and third place are all different, right? If one horse gets first versus second versus third, we care about the order that they go in. So this is 10 factorial over 10 minus 3 factorial. Now, please don't just do this on your calculator. I want you to show your work and go 10 times 9 times 8 times 7, and then now that the denominator matches, right, we can cross those out. So now we have 72 times 10, which is 720. Okay. So I am going to test you to see if you can do this without a calculator. And then I'm actually going to show you how to do this one with a calculator. Okay. So calculator for 10p3 is, if you go to, well, first you have to type 10, and you go to math, probability, and right there, that gives you your third number. Okay, so I'm going to write this in. You have to type your number first. Then you go to math. Our chapter is probability right now. Oops. PRB. And then I'll show you again. So we go into math, probability, and then not 4, but 2. And so now when you do that, we can also check that our answer is correct. So I'll be asking for both. I am going to say that you can use this in certain problems, but other places I'll say you must show your work. Okay. So let's take a moment and think about how can we find probability using permutations. Well, probability is like sum over the whole, right? Sum over all. So we're going to ride on a float with our soccer team. There's 12 floats total in the parade, and their order is chosen at random, right? So what's the probability that your float is first and the float with the school chorus is second? So this is a little bit like our 3 shots problem, where you want to think about all the different events that are happening. So first you have to pick soccer. And then chorus has to happen. And you can't forget about the rest of them, okay? Because there's 10 more floats that have to happen. So you do have to consider that it's not just taking the first 2 floats. We have to consider the rest of them as well. Okay. In this case, it doesn't actually make a difference, okay, but later it will. So I'm going to put in that there are 10 more floats. Okay, so there's 1, this has to happen, 2, and then 3. So how do we write this? Well, we want the probability of getting us first, right? So there's only one way to make this happen. Okay. And then there's only one way for the chorus to be picked second. And then there's 10 more, which is we don't care about those 10. Okay, sorry, in my notes I had a different number and I was really confused. I changed it for some reason. Okay, so now let's assume that since we're doing probability, this is like what's going to happen, right? We want this to happen. And then this is total outcomes. So this is if I have 12 floats and I choose 12 of them. Okay. Well, 1P1 and 1P1 are actually just 1, so I can check this one. Ready? As you guys do more, you'll, oops, sorry. You guys will get comfortable and see it. Okay. So that's 1 times 1 times, and then 10P10 is just 10 factorial. Okay, I'll show you that on the side. Remember we said 0 was 1, right? Okay, well 12P12 then is 12 factorial. And so what I want to do now is reduce my fractions. I have the smaller factorial is my goal to cancel out, right? So I want to cancel out 10 factorial. And you see how it's 12 factorial, 12 times 11 times 10. So what you have, the probability of having your float first and the school float second is 1 out of 132. Let me just check that I multiplied that right. Yes. Okay. You can leave that as a fraction. Okay, so this is where it gets a little bit more complicated, and this is why I showed these even though they were like choosing one and choosing one. So on this town parade, you're still with the soccer team, 12 floats applying, but only 5 are going to be selected. So this is different now because I'm not going to choose all 10 of them or all 12 of them. I'm only choosing 5. So your float has to be first. Float with the school chorus is still second. Okay? But there's only 5 total. So let's see. We're going to have probability of soccer first. And then chorus second. And not 10 more, but 3 more. Out of the 12 total. I'm going to write here. Oops. Only taking 5 of the 12. So we're going to have 12 choose 5, right? And then the question is then what is the chances of these 3 things happening? So we're going to have soccer first. That's 1 permutation 1. Chorus is also the same. But now we only want 3 more of the 12. So we're going to have 12 choose 3. Okay. And so once you have this, then we can keep going with our calculator. I know that these are 1. And then, 12 choose 3. I'm going to go 12, math, probability, PR 3 is 1320 over 12 choose 5 is 95040. And if you divide those, I don't need these reduced. Oops, 1320 divided by answer is 1 over 72. Right? Or a 1.4% chance. Okay. Let's move on and do the last topic. And this is going to be very, very similar, so we're going to move through this fairly quickly. Now, the difference is we're going to talk about combinations, not permutations. So a combination is a selection of objects in which order is not important. Okay. For instance, if we're drawing 3 prizes that are exactly the same, you would use combinations because getting the first prize is not different than the second prize or the third prize. Okay. So the word you're looking for is combination, or the scenario has to happen where like the order doesn't matter. So count the possible combinations of 2 letters chosen from the list A, B, C, and D. Okay, so if I'm choosing 2 letters, I can do A and B, A and C, A and D, right? And then I can do B and C, B and D, B and A repeats, right? And so the last one we can do is, I've lost track of it, A, B, B, C, C, D. Oh, I can do BT. Oh, I'm missing one. CA. Oof. I don't know. This is where I would like really have to. There is one more though. Okay. So if we can find it using an organized list, sorry, I'm just gonna write here one more, because I actually don't want you guys to use this method anymore. We can use a formula. So this formula looks almost exactly the same. Instead of NPR though, it's NC for combinations R equals n factorial over n minus r factorial, and then on the denominator there's another r factorial. So we're dividing by more terms now. So if I take 2 of the 4 objects in any combination possible, I'm going to have 4 choose 2, and 4 goes on top. On the bottom, I had 4 minus 2 factorial times 2 factorial, and so I have 4 factorial over 2 factorial 2 factorial. One of the factorials cancels out, and the other one has 2 times 1, and I can reduce those, and so that gives me 2 times 3, okay, which is 6. So let's use our formulas now. We order a sandwich at the restaurant. You can choose 2 side dishes. Does the order matter if you order first or second? No, right? Order doesn't matter. So this is going to be, out of 8 total, I'm going to choose 2 and C because the order doesn't matter. So this will be 8 factorial over 8 minus 2 factorial times 2 factorial again. And so I can show my work. 8 times 7 times 6 factorial can cancel with 6 factorial, and then I'll have 2 times 1. 8 divided by 2, that becomes 4. So 4 times 7 is 28 ways. Or 28 combinations of side dishes. Should write combinations. Okay, last problem. Sorry, this is a little bit long. So finding a probability using combinations. So if we're selecting 14 photos, including one of you and one of your friend, right? So this one's going to be very similar to the one that we did before. I'm going to have you guys try this. Very similar to this one, just with choosing. So it's a combination instead of permutation. I'll give you the answer in just a second. You guys should. I think that's my answer, but I did work fast. Check my work and see if you get the same one.